take a look at chapter 7, which is all about graphs and measures of center. So if you've ever done anything with mean, median, mode, range, you'll know what I'm talking about. So 7.1 is all about graphs. In the business setting, graphs are used often to bring home the point. A lot of people are visual learners, so any type of graph you can show them is very helpful. Some common ones are line graphs, bar graphs, circle graphs. So some line graphs, here's one. It's the average Valentine's Day spending by year. So it went up quite a bit. Look at this. The average was $125 per person. Whew. And then it dropped. I guess people, maybe there was a crash in the market. And then it's been going up again. You might be asked some questions based on a line graph. So what is the increase in spending from 2006 to 2007? So you basically want to look at the Y values and find the difference between the two. So this is at an average spending of $100 per person. This is at an average spending of $120 per person. So it went from 100 to 120. Oops. So I'm going to just subtract them, giving me $20. So it went up by $20. What is the percent increase? Okay, so to figure out the percent increase, I take how much it went up and I divide that by the original amount. So the first number. So I'm going to take the 20 and it went up from $100. So 20 divided by 100 is 0.2, which is 20%. Or if you remember, percent is per 100, so you could have just looked here to figure it out. So it went up 20%. Oof. Okay, some bar graphs. So make sure you have labeled your graphs. The intervals should be equally spaced. If you've seen a histogram, it's basically like a histogram, only the histogram, the bars are next to each other. And typically that's using ranges of numbers. You can use horizontal or vertical bars, so going up and down or left and right, but they should be the same width, I should say. So some examples. This is how far back your seat tilts on an airplane. Here's yours. This is in degrees, right? And here's the guy in front of you, right? If you don't know U2 songs, you may not get this one, but things Bono has found. He's found his car keys 100% of the time, change under the couch 100% of the time, the love of his life 100% of the time, what he's looking for 0% of the time. So if you know the song, still haven't found what I'm looking for? That's the joke. Okay, fruit sales. So these are different types of fruits. So histograms have to have numbers here, whereas bar graphs don't. So that's one of the differences between bar graphs and histograms. This is the sales of apples, bananas, grapes, oranges, and pears. Notice they even use the colors to help us out here. What percent of fruit sales were oranges? Okay, so if you look at oranges, there were 50 oranges being sold. But the question was what percent of fruit sales were oranges. So I need to know 50 out of the total. And that'll give me the percent. So I'm going to need to figure all these out and add them together to get the total. So there were 40 apples, 60 bananas, 30 grapes, we already said 50 oranges, and that looks like 25 pears. So if you add all of those together, you get a total of 130 plus 50, 180, 205. And then for percent, you just divide. So you're going to do 50 divided by 205. Oops, get out my calculator. So 50 divided by 205 gives you 0.24, which is 24%. So almost a fourth, right? Because 25% would be a fourth, which almost a fourth of your data is oranges. Okay, here's an example of a circle graph. If you are familiar with Dave Ramsey, he's a financial guru. He has something called Financial Peace University, where he teaches people how to spend their money appropriately. He's on a radio show as well. So these are some of his recommended budget percentages. So notice that in a circle graph, you separate it, they're usually percents. So, and these percents should add up to 100%, because a full circle is 100%. So, he says you should spend about 30% on housing, 15% on savings, 10% on charity, 10% on food, and 35% on everything else. So you'll notice that in a circle graph, these little portions or parts or sectors, whatever you want to call them, of the circle graph are supposed to be representative of the percents. So 10% of the money should go towards charity. Well, they tried to make 10% of their circle drawn here to represent that. A fourth of the circle would be like here, right? And 35% is a little more than a fourth, so that's why this chunk is a little bigger than 25%. So the way you can do that, if you wanted to be super precise, that's what this is saying. So in a full circle, there are 360 degrees. So I don't know if you have a protractor, if you own one, but if you wanted to be super accurate, you could say, all right, well, let's say I want 10% of my circle to be food. Well, let me figure out 10% of 360 degrees. That would be 0.10 times 360. That's 36 degrees. So then you could use a little protractor to measure 36-degree angle, and that'll make it more precise. Okay, so I thought this was interesting. This was actually on the news from 2012, and it said 70% back Palin, 60% back Romney, and 63% back Huckabee. Okay, do you see a problem here? These numbers, if you add those up, way over 100%. So this is not a good use of a circle graph. Okay, we're not going to do that. Okay, so this is average time used for high school students. There's a little key here on the side. So how many total hours are there? Well, in order to figure that out, we have to add all of these together. So if you add 8.6, 6.3, etc. Now we know what it should come out to be in a full day, but let's just add and see what we get. So I got 8.6 plus 6.3, and going counterclockwise, plus 3.6 plus 1.6 plus 1.1 plus 0.9 plus 0.8 plus 0.8 plus 0.4. Now, the reason I added them, I knew there were 24 hours in a day, but it comes out to 24.1. Now, this could happen because these are all rounded numbers. So maybe one of them was like, maybe this was 6.29, but maybe another one was like, this was 8.59, maybe, or maybe they were all over this, like 6.31, 8.61. They were all a little over, so then together they combine to 24.1. So as long as it's within a few decimals, you're good. All right, what percent of the day is spent at school? Well, if you look for school, that's the red one, so 6.3, and percents we want to find percents, you always want to take the number and divide it by the total. So we're going to take this and divide it by the total, which was 24.1, and then that'll give you a decimal, which you'll have to convert to a percent. But we get 6.3, divided by 24.1 is 0.26. So then if you move the decimal over twice, you get 26%. So about a fourth of the day is spent at school, in high school. We're not going to do that activity. Okay, 7.2 is about mean, median, and mode. So hopefully this is review for you, but the mean is basically the arithmetic average of a set of data values. So you find it by taking the sum of the values, so adding up all the numbers, and then dividing by the number of values, so dividing by how many there are. So if you want like the average number, you add them all up and divide by how many there are. So if I wanted the average test score, I take everybody's test score, add them together, and divide by how many students there are. So it's basically the same thing as the average. However, mathematicians don't like to use the word average because technically all of these are types of averages, but the way that the word average is used is basically the mean. The median is the middle value of a data set. So mean, I've heard that described as the meanest one because there's a lot of math involved. The median sounds like middle. There's an M and a D, just like M and D in middle. It's the same number of letters as the word middle. The mode is the most often, so it sounds like most. So it's the value that occurs the most in a data set. So if you have a data set and there are like 5 of the same number, and all the other numbers only appear once, then it's going to be that number that appeared multiple times. There could be more than one mode. There could be no mode if all the numbers appear the same amount of times. So if like every number only appears once, there's no mode. You could have a couple modes, just one mode, etc. Okay, so we're not going to do that, but if you were in class, we would. Okay, so a frequency distribution. A frequency distribution is basically a chart. It's also called a frequency chart sometimes, where you have class intervals, which are categories for grouping the values. So like 30 to 35, 36 to 40, etc. Okay, tally, so that's, you could either make tally marks or just put the number. The frequency, that's the number of tallies. So that's the number of times that some number appears in your interval range. So if I have a 32 and a 33 and a 34, there are 3 numbers that appeared in that data set. Grouped frequency distribution is a compilation of class intervals, tallies, and class frequencies. And then relative frequency is talking about the percentage of the frequencies. So regular frequency is just the tally marks. Relative frequency is the percentage. So here's some data. Let's say I have these scores, 78, 84, 95, etc. So I'm going to make a frequency distribution. Now typically a histogram or bar graph is based off of your frequency distribution. So first thing I need are some intervals. Now sometimes you can choose your own, but they've given us some interval ranges to use. Now these intervals should be what we call the same width. So like 75 to 79 is 4 numbers, 80 to 84 is the same number of numbers. So you actually, technically it's 5 numbers if you include 75, 76, 77, 78, 79. And then here that's technically 5 numbers, 80, 81, 82, 83, 84. So if you notice, these are called the lower class limits right here. They should go up by the same amount. So this goes up 5, and then 5, and then 5. So you shouldn't have one that's like 75 to 76, and then 77 to 84. That just doesn't make sense. They need to be the same, be consistent with your width. So I can write, oops, I'm going to do this as we go. So 75 to 79, got 80 to 84, 85 to 89, 90 to 94, and 95 to 99. Okay, the class frequency, so that's the number of times we get a number in this interval range. So I'm looking for all the numbers in between 75 and 79, also including 75 and 79. So 78 is in between there, so there's one. Let's see what else we've got. And 77, so there's two. And I like to cross them off as I go so I can keep track of them. Okay, so now the next frequency, 80 to 84, we'll look at that interval. I've got an 84, and it looks like that's it. Okay, now the next interval, I've got 85 to 89, so I've got an 88, an 87, and that's it. From 90 to 94, I have a 94, I've got a 90, oh, forgot this one, and a 92. And then from 95 to 99, I've got a 95 and a 99. Now, I also double check that I've gotten all the numbers here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So if I double check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm good. So this would be an example of if I just wanted a frequency chart, I could stop there. And sometimes you'll see it written as numbers instead of tally marks. So this would say 2, 1, 2, 3, 2. Okay, now to figure out the relative frequency, remember that's the percent. So to find the percent, I'm going to take the frequency and I'm going to divide it by the total, because I want the percent of numbers that occur in this interval range. So they've given me a spot for calculations. That usually doesn't show up on your relative frequency chart, but they've given us a spot to do that, so let's take advantage of that. So I had 2 numbers, and I had a total of 10 numbers. So I'm going to do 2 divided by 10. That gives me 0.2. And if I change that to a percent, I just move the decimal over twice, I get 20%. Okay, the next one is 1 out of 10. So 0.1, which is 10%. So 10% of my data values were in this interval. And then I have 2 out of 10 again, which is 0.2. So these are all going to be divided by the same number. It's the total number of scores you had or data values. Okay, this one is going to be 3 divided by 10, which is 0.3, which is 30%. Oops, forgot to write that one. Here I've got 2 divided by 10 again, which is 0.2, which is 20%. Now, these should all add up to 100% because this is 100% of your data. And just like the example with the circle graph where it was slightly off, sometimes you could be a little over, a little under 100% just because of rounding, but it should be very close to 100%. So this is regular frequency or class frequency with tally marks, and then relative frequency is the percent. So it's still representing the same data, it's just in percentage form instead of tally form. Okay. So now for grouped data. So this one, I'm going to use the same intervals. So the same data here. Actually, do I have that listed already? No. And we had 2, 1, 3. Let's double check this again. 2, 1, 2, 3, 2. 2, 1, 2, 3, 2. Okay, so now let's say I want to find the average. Now, if I wanted to find the average of these data values, oh, that reminds me, we didn't go through how to find those. So let me go back after this slide to actually calculate those things. So if I wanted to find the average of these values, I could just add them all up and divide by how many values there are, right? Well, let's say I didn't have this information and all I had was this chart. Well, I don't know the average because I don't know the exact numbers. I know there were two that were somewhere between 75 and 79, but it could be 76 and 77, it could be 75 and 78. I don't know exactly what they are. So what you do is you find the midpoint of these two numbers. So I'm going to find halfway between 75 and 79. So if I do 75 plus 79 divided by 2, I get 77. That's halfway between 75 and 79. So that's the midpoint of those two numbers. So I'm basically saying, well, I have two numbers somewhere in between here, so I'm going to just assume that those two numbers were each 77, because that's kind of the average of these values. So then to find, so each number would be 77, so I have two of those. So then here, I'm going to do 2 times 77. Okay, so now I have 80 to 84. There was one number somewhere between there, so I'm going to take the halfway point, which would be 82, and I have one of those. And then here I have two numbers. Halfway between 85 and 89 would be 87, so I have two that are about 87, and I'm just using 87 because I don't know exactly what numbers they were if I didn't have this. So I'm going to call it the midpoint of the interval. Okay, and then between 90 and 94, halfway is 92. I have three of those at 92. So that's what this is saying. Product means multiply. So I'm going to multiply the midpoint and the frequency, which is what I'm doing. And then here, halfway between 95 and 99, the midpoint would be 97. And I have two of those at 97. So, when I add those together, I get a total of, right here. If I were to multiply and add, I get 880 right here. So I'm saying when I add all these numbers together, I'm probably going to get about 880. So remember, to find the mean, you take the sum of all the numbers and you divide it by how many numbers you had. Well, how many numbers I had is basically the frequency. I had 10 numbers, right? 1, 2, 3, 4, 5. I had 10 numbers. So to find the mean, I'm going to take 880 and divide it by 10. So the average number will be about 88. And if you look at our results, it does look like they're all somewhere around 88, right? So the average would be 88. So that's how you find the mean in group data. Okay, so I want to actually go back because I introduced to you mean, median, mode, but we didn't do the activity, so we didn't actually calculate the mean, median, mode. So let's say I have some numbers, 5, 7, 12, 14, 18. 18. All right, so the mean is going to be the average of all the numbers. So since I have the data values, it's not group data, it's just normal data. I'm going to basically just add all these up. And then I'm going to divide by how many there are. Well, if we count 1, 2, 3, 4, 5, 6, there are 6 numbers. So if you add these, you get 12 plus 12 is 24, plus 14 is 38, plus 18 is 56, plus 18 is 74. We're going to divide that by 6, which gives us 12.33. So that's the average number. So if you look in this data, the mean, the average of the data set is 12.33. And a little side note, if you have an outlier, so let's say I had a number that was like, I had all these and then I had the number 100. that's going to make your average increase because you're adding in 100. So your mean will be skewed. It'll be way higher than it should be. So the mean is not really a good measure of center to use if you have an outlier. Okay, the median is the middle number. So you want to arrange the values in order from lowest to highest, and then just count over to find the middle. So cancel those, cancel those. It's going to be somewhere in between these two. Now if you had an odd number of data values, so the middle would just be 10, right? You just count over its middle number. But when I have an even number, it's going to be halfway between two numbers. So then you'll have to find the mean of the two middle numbers. So I need to find the middle of 12 and 14. So you can do that by averaging them. So adding them and dividing by 2. Or just knowing 13 is halfway between 12 and 14. So that's the median. And the mode, if you look here, 18 occurs the most often. So the mode is 18. Now let's say I had another 5 here, then the mode would be 18 and 5. Okay, but that's not the case. Alright, I apologize for not doing that earlier. Okay, so let's move on to finding the percent above and below a data value. Okay, so what percent of the students scored above an 85? So let's look at first how many of the scores are above 85. We've got 1, 2, 3, 4, 5, 6, 7. So 7 of the values are above 85, and remember percent, you always put it over the total. So there are 10 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 7 out of 10. So if I divide those, I get 0.7. Move the decimal over twice for a percent, it's 70%. So 70% of the students scored above an 85. Okay, measures of dispersion. So the last 3 we did, mean, median, mode, they kind of tell you the center of the data, which is why they're called measures of center. It tells you kind of roughly where the middle is. These 2 values, they tell you how spread out data is. So range and standard deviation. So to do that, let's look at an example here. So try to decide where I should move, either Queen Creek, Arizona, or Honolulu, Hawaii. Okay, you may have different preferences and different reasons for choosing, but I want to choose one based on weather. Okay, well, Queen Creek gets really hot. Honolulu is pretty nice and moderate and tropical. So I'm going to do it based on the average temperature. So let's look at the average temperatures. Here's Honolulu's, and here's Queen Creek's. So if you notice, Honolulu stays pretty consistent, and Queen Creek is all over the place. The lowest it goes is 66, and the highest it goes is 101. And these are the average monthly temperatures. So let's find the average temperature for each city. So if I find the average, remember that's where you add them all up and divide by how many there are. So when I do that, I get 80 plus 80, plus 81, plus 83, plus 85, plus 87, plus 88, plus 89, plus another 89, plus 87, plus 84, plus 81. So that's 1,014, but then I have to divide by how many there are to find the mean, right? So 1,014 divided by 12 gives me 84.5. So that means the average monthly temperature is 84.5 degrees. All right, for Queen Creek, let's do the same thing. So here I'm going to do 66 plus 70 plus 75 plus 82 plus 91 plus 100, it gets really hot there, plus 101 plus 99 plus 95 plus 85 plus 74 plus 66. So that's 1004 divided by 12. That gives me 83.7 degrees. All right, this is really not a significant difference at all. So that's really not going to persuade me. So maybe the mean is not a great representation. And I bet the median wouldn't be either. So maybe I should look more to see if how consistent the temperatures are. Now you can probably tell by looking at this which one's more consistent, but if you can prove it to me with numbers, it's going to make a much bigger difference. And that's especially in the business setting. Numbers persuade people. So it's good to know how to find these different measurements. All right, so one thing I can look at is the range of values. So to find the range, I just take the maximum value and I divide it by the minimum value. So if I look at Honolulu, the highest value is 89 and the lowest is 80. So if I subtract those two, I get a range of 9 degrees. So it only varies by about 9 degrees. Queen Creek, the range, the highest was 101 and the lowest was 66. So that is a difference of 35 degrees. That's significant difference. So if you look at the lower the range, the least spread out the data is. So a 9 degree variation is much smaller than a 35 degree variation. So that might be a good selling point, right? If you don't want a lot of change in your temperature, then you'll look for the lower range. Now, one downfall of the range is that it's very sensitive to extreme values. So if you have an outlier, like I talked about before, with a number that's way higher than the rest or way lower than the rest, that is going to be taken into account with the range because you're subtracting the highest and lowest. So maybe the rest of the data is all close together and then there's one way above, then the range may not be a good representation. A couple of rules: when rounding, use one more decimal place than the original data. So here I would want to actually probably use 9.0. Notice I used 83.7 instead of just 83 or 84. Because this was rounded to no decimal places, so I'm going to give my answer as 1 decimal place. If there was 1 decimal place, then my answer would be 2 decimal places. Okay. So that's range. But another way you can measure consistency and dispersion, how varied the data is through a measure called the standard deviation. And if you've ever taken statistics, you've dealt with standard deviation. So to find standard deviation, first thing you need to find is the deviation. So deviation is how far something deviates from the mean. So basically how far away it is from the mean. So to find how far away it is, we find the difference between the value I'm looking at and the mean. So first thing you need to do is find the mean. And then you just find the amount that each data value deviates from it. When the value is smaller than the mean, you're going to get a negative number because you take the value and subtract the mean. So if the value is larger than the mean, you'll get a positive. But if the value is smaller than the mean, you'll be taking away a higher number and you'll get a negative. So that's how you'll know if the number is below or above the mean, is based on its deviation, being positive or negative. Okay, so for standard deviation, you're going to do a couple things. Yes. So for standard deviation, you're going to first find the deviation. Let me tell you what it is first. A statistical measure using the square of each deviation from the mean. So you're going to take each data value and subtract the mean from that data value. That's going to give you each deviation. Then, because you don't want to be worried about positives and negatives, you're going to take that deviation and you're going to square it. You're going to square all the deviations, then you're going to add them all together. But then to take care of the square, you're going to end up square rooting in the end. And this might sound like gibberish right now, but I'll show you an example in a moment. But the number you get before you square root is called the variance. So let me show you this. So how to find the standard deviation? First you find the mean. Then you find the deviation of each value from the mean. So if you have 5 data values, you're going to have 5 deviations. If you have 10 data values, you'll have 10 deviations. You're going to figure out how far each number is away from the mean. Then you're going to square those numbers so that you don't have to worry about negatives because anything squared is positive. Then you're going to add all those numbers together. And then you're going to divide it by 1 less than the number of values in the data set. So if you have 10 numbers, you're going to divide that number by 9. If you have 6 numbers, you're going to divide that number by 5. And that number is called the variance. And then you can use the variance to find the standard deviation by square rooting it. Okay, so let me show you with an example. So find the standard deviation. So, we'll start with, first thing you need to do is find the mean. So to find the mean, I'm going to add all these numbers. I would show you this with the Queen Creek and Honolulu example, but this can get really long, so I'd rather do it with a small data set. So I'm going to add them all together and divide by how many numbers there are. There are 4. So when I do that, I get 24. Oops. Okay, so we're going to write each value here. So I've got 18, 22, 29, and 27. And the mean is 24. And the mean's the same, right? I already calculated the mean. Now I want to find the deviation from the mean. So I'm going to take the value minus the mean to get the deviation. So 18 minus 24 is -6. Here I'm going to do 22 minus 24, which is -2. Notice I'm getting negative values because these numbers are less than the mean. Here, 29 minus 24 is 5. That's positive because this was higher than the mean. And here, 27 minus 24 is 3. And it's positive because 27 was higher than the mean. Okay, these are the deviations. And now here I'm going to square those numbers. So I'm going to take -6 squared, which is 36. And if you're doing this in Desmos or another calculator, if it's a negative, you need to put it in parentheses before you square it. Otherwise, your calculator is going to tell you it's -36, which is not true. Everything squared is positive. Here, -2 squared is 4, because that means times itself, right? So this was a -6 times a -6. That's what squaring means. This was a -2 times a -2. 5 squared is 5 times 5, which is 25. 3 squared is 3 times 3, which is 9. Okay? Now, the next step, if you look at this table, I found the squares of each deviation. I'm going to now find the sum of all those. So I'm going to add all those together. So if I add these, 40, 65, 74. So that's the sum of the squares of deviation is what this number is called. Okay, now, to find the variance, I'm going to take the sum of the square deviations, so this 74, I'm going to divide it by n minus 1. N represents the number of data values. So I've got 74 divided by, I had 4 data values, right? So n is 4, so 4 minus 1, which is 3. So I get 74 divided by 3, which is, I can't see that, 24.667 or 0.67. And remember, we can round to one more decimal place than is there, so really you could say 24.7. So that's the variance. I guess that doesn't have the same rule though, so we could go farther to be more accurate. Okay, and then the standard deviation is just whatever the variance is, square rooted. So it's that 24.67 number, square rooted, which is 4.97. So the standard deviation is 4.97. So what that means, this number, what does standard deviation even mean? It means that each data value on average varies about 4.97 from the mean. So they're all about 4.97 away or 5 away on average. So notice some of them were more away. This was actually 6 away. This one was less. It was only 2 away. But on average, they're about 4.97 away from the mean. Okay. Another one last topic, normal distribution. So if something is normally distributed, that means it makes this perfect bell curve. And there's a rule, it's called the 68, 95, 99.7 rule, that says that if something is normally distributed, so if it makes this nice bell curve, then 68% of the data falls within 1 standard deviation of the mean. About 95% of the data falls within 2 standard deviations of the mean. And then about 99.7% of the data falls within 3 standard deviations of the mean. So almost all of the data that you have should fall within 3 standard deviations of the mean. So only outliers would be outside of that, right? Like 0.3% of the data. So this is 0 right here. And these are the number of standard deviations from the mean. So if it's 0 away from the mean, that means it is the mean. So this number 0, this represents the mean. This +1 means +1 standard deviation, so that's 1 standard deviation above the mean. -1 is 1 standard deviation below the mean. So this rule said that 68% of the data is within 1 standard deviation of the mean. So that could be 1 above or 1 below. So notice right here, here's 1 below, here's 1 above, if this is the mean. And 68% of the data falls within 1 standard deviation. And so this is more precise, 68.26 instead of just 68. And then this is perfectly symmetrical, so they just cut them in half. So half of 68 is 34. So that means 34% of the data is from the mean to 1 standard deviation below the mean. Also, 34% of the data is from the mean to 1 standard deviation above the mean. Okay, then here's 2 standard deviations above and below. That's 95% of the data, right? Well, they've already used up 68% right here. So if I do 95 minus 68, I'm left with 27% of the data to fit into these 2 spots. So if you cut that in half, it's about 13.5% in each one of these slots. And then There's 2.15% in each one of those slots and 0.13% in each one of those slots. Okay, you don't really need to know how to create this graph, you just need to know how to use it based on your data. So, let's look at a problem. I just wanted to show you that so you're familiar with how they came up with those numbers. Alright, so the weights of stray dogs at a particular pound have a mean of 70 pounds. So that means right here, this 0 mark is 70. Because the mean is that 0 mark. With a standard deviation of 2.5 pounds. So that means one above it, one standard deviation above it would be 2.5 pounds above 70. So I'm just going to add 2.5 to 70 to give me 72.5. So that's one standard deviation above. Two standard deviations above would be another 2.5. So this one's going to be 75 if you add 2.5 to 72.5. And then 3 standard deviations above is another 2.5 away. So that'll be 77.5. Okay, now if I want to label these ones, now I'm going below the mean. So now instead of adding 2.5 each time, I'm going to subtract 2.5. 70 minus 2.5 is 67.5. And then 2 standard deviations below is 2.5 again below that. So if I subtract 2.5 from 67.5, I get 65. And then this one, 2.5 below that is 62.5. Okay, assuming the weights follow a normal shape distribution. So that's why I'm allowed to use this chart, is because of this statement right here. What percent of dogs weigh more than 72.5 pounds? Okay, so now that we have this all labeled with our data, instead of just zeros and ones and twos and threes, 72.5 is right here, right? Now I want to know what percent of dogs weigh more than that. So more is above, right? This is more, and then less would be below. So I want above this number right here. So that means I'm going to take these numbers, this is a 13.59%, (2.15%), and 0.13%, and I'm going to add those together, because those are the percentages that are above 72.5. If I wanted below, I would add all these numbers together. So when I add all those together, I get 13.59, oops, plus 2.15 plus 0.13, which is 15.87%. So that's the answer to this one. So 15.87% of these dogs weigh more than 72.5 pounds. So now using that information, if there are 100 dogs, how many dogs weigh above that? Well, 15.87% of that. So I'm basically trying to figure out 15.87% of 100. Well, remember when we do percents of, we're basically going to multiply. So make sure you convert any percent to a decimal, so that'll be moved over twice. So 0.1587 times 100, well, that actually comes out to 15.87. You can't have 0.87 dogs, so we'll say 16. So 16 dogs weigh above 72.5 pounds in a set of 100 dogs. Now, if they had said, like, if there are 200 dogs, how many dogs weigh above, then you take 15.87% times 200. And that is it for normal distribution. I'm not going to do that, obviously. So if you have any questions, please feel free to email me. But have a great day.